Hi guys, welcome back to Rancor Exotics. I'm here today with Papaya here, my pastel clown. So today we're going to be talking about genetics and its importance in the ball python community. Now I do have to, give you guys a little statement on genetics about if you're looking into buying a snake and you're researching genetics and morphs, you need to know that there are a group of combinations and morphs that do produce problems. I talked about them a little bit in my other video. However, the morphs in the spider complex, which is spider, champagne woma, hingine woma, super sable, super spot nose, produce neurological defects. There's also different combinations of genes like the super cinnamon that has a propensity to have malformations if in the hatchlings. And there's also different strands of albinism or albino that do produce malformations in the hatchlings as well. Now, after hearing all that, you thinking morphs are bad because health reasons, right? But in reality, that's all those morphs I just threw out are a very small sliver of all the morphs available to you. And if you keep an eye out and you know what pairings are bad, if you're breeding them, it's very simple and very easy to stay away from some of these pairings that could produce malformations in these baby snakes. So these genetics come in three different flavors, right? Regardless of whatever you mix and choose between these three different categories, it's all the same species of snake. It's the same snake, just with a different paint job. Now, the first one would be the codominant. Codominant basically means that you're able to produce super. What supers are animals that carry two genes of the same morph. So that means that pastel girl I had, she is able to pass down one of her that pastel gene 50% of the time. So if an animal that is super or homozygous for pastel that carries two of these genes, when they pass down their genes, it's always 50%. So that means that since they have two genes of pastel, they will always pass one down. So that means all of the animals in that clutch will have pastel, which is great from a breeder standpoint because then it reduces the chances of not producing an animal with any morphs. And it's great for the consumer because these animals look absolutely amazing. There is one animal or one gene that does tend to be a problem, and that would be the super cinnamon, and it produces a very beautiful all black snake. This snake has a tendency to be malformed in the egg with kinks. It also suffers from things like shark bite, where there is an overbite. They look extremely weird. However, once if you do decide to, say, produce some of these animals, the super cinnamon, and they come out of the egg looking absolutely perfect, they look fine, they're eating great, that means that the animal is probably a solid animal and it should be okay. Oftentimes it's not the case, as there are sometimes internal issues that we can't see, but that's the super cinnamon for you. And so this brings me to the second family of genes that we have, which are the dominant genes. Dominant genes are work much in the same way as codominant genes do. However, you are unable to produce supers. Things like pinstripe and calico, though they've been around for quite a long time, genetically they cannot produce supers. Dominant is just a way for breeders to know whether a gene is able to produce a super, because if a breeder has a new gene, they suspect they have a new gene, they very quickly try to produce a super form of it to show off, to market, to show everyone that the gene they have is unique and is different. If they're unable to produce a super, but they're able to see a noticeable difference in this ball python compared to a wild type, then they attach the dominant label on it. Its pinstripe is very noticeable, and it's very obvious that a snake has it. But things like calico, where line matters, the different line of calico you have matters. If you have a regular calico that you picked up from anywhere, it might be hard to see. There might be some white speckling on it, being, you know, the defining feature of it. And then there are other lines of calico where the sides of the snake are just pure white. It looks like a spider, without the dorsal pattern, but just whiteness coming up from the sides, and it looks absolutely beautiful. So again, dominant genes work very much like codominants do. It's just as a way to tell you and inform you that the gene that lies under this family of genes cannot produce a super. Now lastly is the meat and potatoes of the ball python industry, and those are recessives. Recessives, you know, they're clown, albino, pied, monsoon. There's dozens of recessive genes out there, and all of them are quite beautiful. And if you've noticed, they're pretty pricey as well. And their increase in price from, let's say, a clown to say like a pastel. The difference in price lies in the fact in the genetics. The recessives, much like a super, needs to have 2 copies of the gene in order to show. So that clown girl I had, you needed to have 2 copies of the clown gene in her in order to produce a visual clown. Now, when you don't have a visual clown, and you know that a clown is a carrier because the parent was a clown, that means it is heterozygous for clown. That means that that animal has 1 copy of clown and another type of a normal. Now, because it is called, this is why it's called a recessive or a shy gene, you need to have that wild type gene removed. You need to have a double dose of clown or whatever other recessive you have in order to show it. And because of this, you need to have a clown-to-clown pairing, which is expensive and limited in the gene pool or morph pool that you can pull from, and so they're a little more expensive. You can have a head-to-head pairing, which is 50% chance of passing down the clown gene, 50% chance of passing clown gene from each parent, and that means you have a 25% chance of getting a visual clown from that, 75% being hets and possible hets, which, you know, we'll talk about in a second. So it's harder to produce a visual recessive animal, which is why they're more expensive, and you layer on more genetics and it becomes even more expensive. Now with the head-to-head pairing, I say that 25% visual and then 75% hets and others. Now there's going to be a percentage of these hets that are 100% carriers for the clown, and others that aren't, and they're not carriers for clown because you've also passed down a normal genes as well. So it's impossible to tell them apart, a het clown from a normal clown, a het clown from a normal ball python. So a breeder cannot tell you that all of the animals in that 75% of the clutch that you produced are het clowns because they don't know. So they add on a probability of it. So from a head-to-head pairing, 25% of the time you'll have visual clowns, which you can distinguish, and 75% of the time you're going to have 66% probability of het clown or heterozygous for clown. That means that there was a head-to-head pairing saying that there is a percentage of the animals in this clutch that will come out het clown. However, there's also a probability of some of these animals coming out not being carriers for clown at all. So 66% hets are usually much cheaper than a het clown, because for a het clown, you know for a fact that this animal is a carrier for that gene. And this complexity and all of this percentages and knowing what's going on, that factors into the price. Usually breeders tend to stay away from talking about prices and stuff like that in their channel because it's hard as, tell your viewers, I just produced a $6,000 snake that you won't be able to buy. Even though it looks beautiful and you might want it really bad, you won't be able to afford it, or it's out of your price range. That's why it's important to understand that there's a lot of work and a lot of time that goes into recessive projects. Now, this is exacerbated when you're looking for a double recessive. My favorite double recessive would be the Desert Ghost Clown. It looks absolutely amazing, and that's what I'm working towards, and it's going to take a long time for me to get there without shelling out thousands of dollars for it. So it's going to take time, and when I finally get there and I do produce these animals, or that blend of genes, you bet your butt I'm probably going to price them at what the market's asking for, because it takes a long time and it's a beautiful animal. Now, all this talk about genetics, I want to reiterate that morphs are basically just paint jobs for the animal. As long as you stay away from problematic pairings and problematic genes, these are just paint jobs going along with some beautiful animals that have a very docile disposition. They're very slow. They're very, very much family pets. They don't need too much attention. They don't need too much care. They're fine by themselves. They won't miss you. They won't love you. But however, they're very hardy, and they're always there. And they live quite a few years. So regardless of whatever morph that you're going for, or if you're a breeder or you're looking into being a breeder, these animals are long-lived. These animals are hardy. So it's important that regardless of whatever you have, to take care of what you have, right? Alright, and that marks the end of the genetics talk. I highly encourage you guys to go into Morph Market, Fauna Classifieds, to educate yourselves a little bit on what's going on. There's other genes that I didn't talk about, like the desert, and you probably won't end up buying a desert because a desert gene, because they're not really sold because of their genetic problems. So they've been almost completely phased out of the industry. So it's probably why you won't ever find one unless you go out looking for one. And the desert and the desert ghost are very different genes. Don't mistake them for one another. Desert ghost is a perfectly healthy gene. Desert has a problem with their breeding, with their reproductive systems. So know that apart. So I encourage you to look at Morph Market. So go around on Instagram and Twitter and learn, look at more YouTube videos and things like that on the morphology of these animals, because you'll pick this up fairly quickly if you're really looking to get into the community, which is big and is very kind. You'll come to understand that the way morphs work and the reason why things are hets, and why double recessives are so hard to hit and things like that. And so the more you engross yourself in this community, the more you'll learn for you and for your pet, if you're looking to get one or you're trying to get into the business. Alright, well, thank you very much for coming by and watching me for a couple minutes.